Hey, welcome back. Ralph here. This is the RHCSA tip of the day for file system permissions. This is going to be a three-part series. I figured I'd break it down to 3 parts. We could shorten up the videos a little bit. We're going to look at standard POSIX permissions, then we'll look at special permissions, and then we're going to go ahead and look at ACL, try to cover all of our bases in terms of file system permissions. This is certainly something that's going to be more likely than not covered excuse me, on the RHCSA exam. Looking at the objectives here, you'll see here that we have, create and configure, set the group ID for collaboration, create and manage access control lists, and then finally diagnose and correct file system permission problems. File system permissions is really something that's very fundamental. If you can't properly secure your file system, then you can't protect the confidentiality of your information. You can't protect the integrity of your information. And so it is very, very important that you have a firm grasp of this, both for the exam and then also as, in your life as an administrator. So usually when I talk about this, the first thing I'd like to do is sort of give you an overview of file system permissions. And when we talk about standard POSIX permissions, it's a pretty simple model. And when I say simple, simple means a couple different things. To me, in this case, simple means that we have a very small set of rules. So inside of this very small set of rules, it makes it easy for us to remember. We have 3 security principles, and then we have 3 different permissions that we can set. So that's pretty simple. That's pretty basic. That can be kind of complicated from an implementation standpoint because you don't have as many options. But let me go ahead and just let's start the discussion with, just kind of going over, what our security principles are, and then also, what our actual permissions are and how they're affected and how they're applied and the tools that we have in order to do this. So we talk about permissions, as I mentioned, we have 3 what I refer to as security principles. Now, you might hear reference in a couple of different ways, but these are the objects that we can apply permissions to. Okay, and so when we talk about what these actually are, we have and again, we're dealing with the file system here, so we have what we would call the owner of the file. Okay, which is character represented as U. So we've got the actual owner of the file. We have the group, or the group owner. You'll hear it referred to different ways that we can apply. And then we have what's referred to as other, or world, or everyone. Those are the 3 different objects that we can apply permissions to. Okay, so that's it. Okay, for every object in the file system, every directory, every file, they have those 3 security principles that we can apply permissions to. Now, the permissions that we we only have 3 permissions as well. And we have to understand, the effect of the permission based off of, whether we're talking about files or whether we're talking about directories. So let's kind of go ahead and just quickly cover that. And so we'll have a little column for the actual permission, and then we'll talk about files versus directories here. So first off here, we have the permission, and then we'll talk about the effect on a file, and then also the effect on a directory. All right, so the first permission that we're going to look at, we're running out of colors here, but let's go ahead and reuse yellow. We have the read permission. Okay, and the read permission at the file level is basically, an open. You can view the contents of the file. At the directory level, the read permission really functions as a list. Okay, and so when we talk about the read permission at the directory level, you're able to list the contents of that directory. We also have the write permission. The write permission at the file level allows us to change the file. Okay. It does not allow us to delete. You know, I see this mistake being made in different presentations and things like that. The way I describe it is that it's an implied delete. With the right permission, I don't have the right to delete the file, but I have the right to change the file so that I can remove all of the contents of the file. So that's like an implied or an effective delete. Even though I can't actually delete the file, if I can remove all the contents of the file, you know, it really functions as an effective delete. But you do not have the permission to delete the file, which is simply the write permission at the file. Now at the directory level, a little bit different. The write permission on a directory allows me to both create, so I can create new files and subdirectories, or I can delete. And that'll come out in our demo a little bit as we move along. Okay. Now, our last permission here is the execute permission. Basically, at the file level, the execute is a run, so I can run binaries, I can run shell scripts with the execute. At the directory level, the execute is a very important permission because the execute permission is, you know, in a lot of ways, you know, how we control access on the system. The execute permission at the directory level allows, you know, entry into the directory. Okay, and so you have to have execute, you know, all the way back to root in order to enter the directory. All right, now how are file system permissions applied? This is going to be different. Those of you coming potentially from like a Windows background and things like that, or Novell, a lot of file systems will use like an aggregate type of system where you get permissions are a sum of all of the permissions you have from all the different sources. Permissions assigned to you, permissions assigned to groups you're in, permissions assigned to everyone. It's not the way it works here on our Linux system. So here's what happens when you enter into a directory or when you access a file. The first thing that the system does is the system checks to see if you are the root account. Okay, and so are you UID 0? If you are UID 0, then you get the keys to the kingdom. If you're the root account, then you get full access. If you're not the root account, the system checks to see if you are the owner. Okay, and the way I describe this is this is like a firewall. You know, if you guys have ever worked with firewalls before, you know, when a firewall has a, you know, firewalls typically work off of ACLs. They work off of lists of rules that do top-down processing, and they process until they get a match. Okay, once they get a match, they execute the match. Same thing here with your Linux file system permissions. If it determines that you are the owner of the file or the directory, then you get the owner permissions. But it's important to remember that that's all you get. Okay, even if you're part of the group, even if world has full rights to the file, this is a jump rule. This will execute on that match. When it matches that you're owner, you get owner permission. So the owner could have read. The group, which you're a member of, could have read, write, and execute. If you're the owner of that file or directory, you're only going to have read access. Okay, it is not a sum. Okay? If you're not the owner, as you might expect, then the next thing it checks is to find out whether or not, you know, your groups match the group ID or the group owner of the file. Okay, so that it will go out and look at the group, and if you're part of the group, then you get, you know, the group permissions as you might expect. And then lastly, if you are not root, you are not the owner, you are not the group ID, then ultimately you will get whatever permissions are granted to other. So that's how they're processed. And that's an important thing to understand, because that is different than a lot of other systems. In terms of our tools that we have, we're actually doing this because it's important that we know how to do this. If we want to change permissions, and I'm going to focus on the command line tools. You know, you could do this graphically as well, but I'm just going to focus on the command line side of things. Then we would want to use the chmod command. And we can do this either numerically or with characters. Sometimes you hear it referred to as absolute permissions or things like that. But if we talk about the, you know, doing it numerically, or you hear it, octally. It's a 3-bit field, and so the owner, the read permission would be the 4-bit. Okay, the write permission is the 2-bit, and the execute permission is the 1-bit. Okay. From a character standpoint, U, G, and O represent user, group, other, and then the read permission would be R, write is W, and then the execute permission is X. Okay. So if I were going to change the permissions octally, okay, then I could say like 664 and then my target. Okay, so I say schmod 664 target, and the 6 field here. I'll try to do it this way. So I'll draw a little box around 6. That 6 field would be the owner. The next 6 field there, the second value here would represent the group, and then the last one there, would be other. And 6 would be read plus write, 4 plus 2, right? And then 4 would be just simply the read permission. So that's one way to do this. You can do it recursively with a minus cap R and things like that. If you're doing it, using character references, then it would look something like this: schmod, and then I could say user or group or other or some combination. And then I could add permissions, I could remove permissions, or I could set permissions. And then I would select my given permission. So we could say, read, write, execute, or some combination of that on whatever my given target is. Okay. So we use the schmod command to set the permissions and then to change permissions. Okay, so this over here, schmod, is to use to set permissions. If we're changing permissions, then we use the shown command, or the change ownership. Okay, and the syntax there, would be, it would be owner and then some delimiter. I always use a dot. Most documentation we use a colon here, and then the group, and then our target. Okay. There is also a change group command. I don't use it very often, but that would, change group, then your group ID, and then finally, your target. All right, so that's sort of the basics here. We've got 3 security principles, we've got 3 permissions, okay? And then we looked at how these permissions are going to be applied. Okay? So let's take a quick look at an example, and then we'll move on. So, all right. So for our example, I think what we're going to do here is, let me pick a different color here for my pen. Let's create. Oh, that's a little bit heavier than I wanted. We're going to create a directory off of root called accounting. Okay, and inside the accounting directory, we're also going to create a group called accounting. And we're going to create a couple users. Inside this group accounting, we'll create a user called Bob and a user called Joe. And we want to make sure that only accounting has access to our accounting directory. All right. So first thing I'm going to do here, let's get out to root. And let's create our directory. So let's say make a directory accounting, and I'm going to say user add Bob user add Joe, group add accounting, user mod for the accounting group for Bob and Joe. Go ahead and check my work a little bit here. And so we'll say groups Joe, and Joe is in the Joe group in the accounting group. So everything looks like it worked. All right, now to view permissions at the command line, we use a long listing. So let's go ahead and take a look at what currently the permissions are for that directory. So I'm going to say ls-l for a long listing. I'm interested in the directory itself, so I'm going to say D for my accounting directory. So these are the current permissions. So what we see here is these are the permissions that are associated with the owner, it was created by root. So root became the owner. These are the permissions that are associated with the group ID of the file, which is also root. And these would be the permissions that are associated with other. Okay. So I've got a couple of issues here. One, I want to make this, I want a group ID or group owner this directory to accounting. Okay, so I need to change the group membership. I want to get rid of these permissions for everyone, and I want to make sure that my group has the ability to write. Now, so let's go ahead and take care of our ownership first. So the first thing I'm going to do is I'm going to say change ownership, and this is the way I always do it. I could use change group here. I'll leave the owner field blank. I'll say dot accounting for root accounting. All right. Now I rerun my ls command, and you'll see that accounting, okay, my update occurred, is now group ID. Now, in terms of changing the permissions, I could do this a variety of different ways. If I say chmod, and then I say 770, that would be read, write, execute for the owner, read, write, execute for the group, and no permissions for other. That would be, one way of doing it. Okay. I could have also, said chmod, group equals read, write, execute, and, other minus read, write, execute to make sure those permissions got removed for accounting. That would work too. If we look at the directory, looks like our permissions are ready to go. Okay. There's no permissions for other. Now, the first thing I always like to do is I like to test the negative. And so I'm going to SU out to my student account. And you'll see here, if I type in groups, student's not part of the accounting group. So when student attempts to enter the directory, student doesn't have the execute right, student gets permission denied. That's good. Okay. All right. So as ID 1000, no success. Okay. Now, if I SU out to Bob, and so I'm now ID 1001, Bob, if we just double check, but Bob is a member of the accounting group. So Bob should be able to change into that accounting directory. Bob can't. Okay. As a member of the accounting group, because I have the create the write at the directory, I should be able to create a file. So we'll create a file called Bob test. Okay. And let's just say Bob was here. Save that. If I do a ls-l here, you'll see here that my new file was created, Bob test, and Bob's the owner, Bob's the group ID, read write, and it's read for everyone else. Okay. So now I'm gonna go ahead and SU out to Joe. And Joe is also a member of accounting. So I should be able to go into the accounting directory. If I do an ls-l here, and I say, well, what should Joe be able to do with this file? Well, Joe's not Bob. Okay, so I don't have those permissions. Joe's not in the Bob group, so I don't have those permissions. So I'm going to get the permissions for other, which means that I should be able to view this file. Okay. All right. Great. Let's try it. So I say cat Bob test. There it is. Bob was here. All right. Now, if I bring up an editor like Nano and I say I want to edit the Bob test, okay, and so I come in here and I say, you know, Joe was here. Okay. And then I go out here and I try to write out my changes. Okay. And so to write it out, it's a Control O. See down here. So I want to save out my changes, do a Control O. It says name of the file you want to write. And I get permission denied. And that's what you'd expect, right? Because I only have read access. I don't have write access, so I'm unable to modify this particular file. Okay. So I'm going to go ahead and do my Control X to exit. And I won't save my changes. And there we go. I'm out. Now, all right, that worked. Okay. But so I can see the file. I can't change the file. Can I delete the file? Well, if we look at the permissions at the directory, at the accounting directory, I have read, write, and execute. So when I say I want to remove Bob's file, it lets me. Okay. And it should. I mean, I have the appropriate permissions. That may not be the behavior we want. We're going to look at in the second piece, you know, how we can kind of, you know, quote unquote, fix that. But the right permission at the directory gives me the ability to delete that file, even though I don't have the ability to change it. And I might not even have the ability to see it, right? I might not even have read access. And so, you know, that may be something that, you know, needs to be addressed. And we're going to look at that in that second piece. But, you know, understand that the right permission, you know, at the directory level is a very powerful permission. It allows you to both create and delete files and subdirectories. Okay. So, all right. One other thing, just as I told you that, you know, the enter permission is a very important permission. You know, I'm in root's home directory. And if I look at the contents of, you know, root's home directory, you'll see there's a file here, for example. There's not a lot in here, but I've got this initial setup kickstart file. And if we look at the permissions, everyone has read permissions to that particular file. Okay. So if I go and I change out to, let's say, the student account, and I see that, and I access that file, and the answer is no, because if I do an ls for, you know, root's home directory, I don't have the enter right. You know, if we do a long listing of root, and we look at the permissions on root's home directory, you'll see that other has no execute. So other can't enter that directory. So even though there's files inside of that directory that I theoretically have, you know, permissions to, you know, that execute right at the directory level is very important for controlling access. All right, but that, I don't want to get too complicated here. Just wanted to kind of go through the basics. So we've got just a quick review here. Our 3 security principles. We've got the owner, we've got the group, and then we have other or world. Okay, and then the 3 permissions that we apply are read, write, and execute. The 2 tools that we talked about were the chmod for changing permissions and the change ownership or shown command. There is also a change group command. But when we come back and look at part 2, we're going to start taking a look at special permissions and how to affect some of that you know, behavior that we saw here that we may want to the system to behave a little bit differently with. So we'll see you back for part 2.